Good day and welcome to my YouTube channel. I am Arthur Francis Devan. I advise you to subscribe and press the like button. Today we'll be taking on data handling, statistical aspect of the data handling, which is standard deviation and pool standard deviation. We know too well that standard deviation is an important tool when it comes to statistics. In short, it's one of the most vital tools because it deals with the aspect of precision, spread. It gives you the concise nature of the value which you need. But in our quest of dealing with our statistical affiliations, it is also important that we know how to do the calculations therein properly. Standard deviation has been taught at various classes of learning, from the elementary, the undergraduate level, and even the postgraduate level. So we're going to look at the formulas in all ramification and see how the deviation exists between them and the most precise formulas which we're going to use in terms of solving these questions as we proceed further. So let's take at our primary level, the first formula here is now if you look at these formulas, this one is used at our elementary level to solve. As we proceed further, you realize that the error margin between the secondary level and the tertiary level is much. So we have to close the gap by introducing, even at the postgraduate level, you realize that this and this will give you exactly the same thing, but this and this may not give you exactly the same with this. Just like in your primary school, they'll tell you 1 minus 2. This is not possible. When you get to your secondary school, they say 1 minus 2 becomes what? Possible, which is minus 1. So that is how we go. But then, we're going to make use of these two as we proceed further to solve all the questions therein. So let's start with this, which is the postgraduate level formula, and see where we get to. But at the end of the day, we're going to compare this and this to see if we're going to get exactly the same thing. Then, and so on and so forth. So it's standard deviation and pool standard deviation. So let's take our first question. We say we should calculate the mean and standard deviation of the following set of results obtained from the volumetric analysis. We have, let's call them our x values. We have 14.67, so our x here is equals to 14.67, 14.69, 15.03. So we're going to calculate the mean and the standard deviation. Okay, as that. So let's proceed. Remember I said we're going to use our postgraduate formula. At the end of the day, we're still going to compare with our undergraduate formula to see if we're going to get the same thing. Now, our formula again for x standard deviation is equals to summation x squared minus summation x squared over n minus 1. So if this is our formula, it means we have to get our values for x squared and x. So here is my x. I have 14.67, 14.69, 15.03. I have another column here for x squared. Means I have to square every variable here. So let's proceed. Now here we have 14.67 square, 0.67 square, 215.2089. So from the formula, what we're having is summation. So we have to sum them all up. and see what we're going to get. So from here, 14.67 plus 14.69 plus 15.03, 44.39. 44.39. Then the second one, 656.9059. Okay, so if we have to apply in our formula, right? Now, the standard deviation says, let's proceed. Our x squared, which is this, the summation of this x squared, which is 656.9009. 656.9059. Minus, now the summation of x, this is x. When we sum it, we square it according to them. So we have summed the x officially, but we have to square it now. So we have 44.39 squared. 44.39 squared. Divide by the number of degree of freedom. We have 1, 2, 3. We have 3 variables there. So over 3, all over 3 minus 1. We move further. I have this down 656.9059 minus, I have to square my 44.39. 44.39 square, that's 1970.4721 divided by 3 in order not to waste time. Now, having divided it, I have 656.824033 all over 3 minus 1 is 2. I'll proceed. This minus this. I have 0.08186 666 over 2, and this is equals to 0.04093. Now, 1, 2, 3, 4, 5. If that is what we have to now look for the root of these to get our final answer. Therefore, our standard deviation now becomes the root of 0.04093 0.202 approximately. Leave it like that. So this becomes our standard deviation. So we're going to take other questions. But remember, I think I skipped something. They were asking us of the mean. So I have not cleaned this. So we're going to get our mean. Okay, let me clean this here. Mean is S bar is equals to the summation of x over n. The summation of x means I add all of these variables of x divided by n, the number of degree of freedom, which is 3. So I have to add that again, which is 14.67 plus 14.69 plus 15.03, which is 44.39. This gives me 44.39. The degree of freedom is 3, and this is equals to, if I divide that by 3, I have 14.8 approximately. 14.8 approximately. So now, by this, so far we've gotten our standard deviation and the mean. We'll take other questions before we go to full standard deviation. Okay, let me get another question for us. Calculate the standard deviation of the following experimental result. Clean this. Calculate the standard deviation of the following experimental result. 2.2, 2.2, 2.4, 2.3. So my x. 2.2, 2.2, 2.4, and 2.3. Okay, if this is true, now we have to proceed to get our standard deviation. So we say earlier on, our standard deviation is equals to the root of the summation of x squared minus the summation of x, the square it over n, all over n minus 1. So, I have my x here again. The values is 2.2, 2.2, 2.4, and 2.3. I have my x squared here, which means I'm going to square it. Then get the summation. So this is the summation here. Let me start with this. 2.2 plus 2.2 plus 2.4 plus 2.3. This is 9.1. So I have my 9.1. So square them all. 2.2 square. I have 4.84. 84. So I have to sum them up. I have my 4.84 plus 4.84 again plus 5.76 plus 5.29. This is 20.73. Okay, here I have squared it. Now I have to put it into the variables they're in. The first formula here says again, let's go. This is the summation of the x squared is 20.73. So the root of 20.73 minus, this is my x. The summation of x, then the square of it, which is 9.1 squared. 9.1 square over the number of degree of freedom, which is 1, 2, 3, 4 over 4, all over 4 minus 1. And this is equals to, I have my 20.73 minus 9.1 square. 9.1 square is 82.81 divided by 4 is 20, 70, 25. 20, 70, 25. Alright, yes. All over 4 minus 1, 3. So this is equals to 20.73 minus 20 point, okay, yeah, sorry, mistake here, 20.70025 is 0.0275. Divided by 3 is this, 0.00916667, which is equals to the root of 0.00916667 is equals to 0.096 as our standard deviation. Remember I said earlier we're going to deal with the pool standard deviation because in pool standard deviation we can have different variables like x, y, and z, which will be required to get their various standard deviation. Because of the complexity of doing that, or the time sake, we use a single formula to compress all of them together to get our final answer. But before we get to that level, let's take another question on standard deviation before we move. The following set of measurements were obtained in a laboratory experiment for the determination of the radius of a metallic ball used in Hooke's law experiment. These are the variables. Let me state them out. All right. So we are asked to determine or find our standard deviation from there. So let's see what we get. So first, this is our y. Which is 12.2, 12.3, 12.4, 12.7, 12.3, 12.2. We have our y squared. Put the summation down. So this is our summation. Now let's see, we have to square all of them. 12.2 squared, 148.84. 148.84. These are the squares of y. So let's see the summation. Start from here, 12.2 plus 12.3 plus 12.4 plus 12.7 plus 12.3 plus 12.2. This is 74.1. Summation 74.1. Now this other way, 148.84, 148.84 plus 151.29, 151.29 plus 153.76, 153.76 plus 161.29, 161.29 plus 151.29, 151.29 plus 148, 148.84. This is 915, 915.31. Okay, our standard deviation now takes this form. This is equals to the root summation of y squared minus summation of y, close bracket, square over n, all the way n minus 1. Now this is my y summation. It's 915, so I have the root of 915.31 minus y squared, which is 74.1 squared, 74.1 squared over n. Over n, sorry. N is the degree of freedom. 1, 2, 3, 4, 5, 6 over 6, all over 6 minus 1. And this is equals to 915.31 minus, okay, 74.1 square is 5490.81. Divide by 6 is 915.135 all over 5, 6 minus 1. So this is equals to, alright, 915.31, 915.31 minus 915.135 is equals to 0.175. Divide by 5 is 0.035. This is 0.035. The root of that will give us the root of 0.035 will give us 0.187. 0.187 as our standard deviation, approximately to the nearest whole number 0.2 or 0.19, any of the above. So this is our standard deviation. Before I get to the full standard deviation, I would like to compare the undergraduate formula and the postgraduate formula and see if we're going to get the same thing, which I know for sure we should. Alright, let's take another question, our last on standard deviation before we move to full standard deviation. The question, in a volumetric analysis carried out in the University of Cross River State, Calabar, in Cross River State, Nigeria, the result obtained was 2, 2, and 3. So let's call that our x, which is 2, 2, and 3. From the result, find the standard deviation. So we're comparing the undergraduate formula for standard deviation and that of the postgraduate. Remember, like I said, we have the two of them here. X is equals to the root summation of x minus x bar square over n minus 1. And we also have x is equals to the root of summation of x squared minus summation of x squared over n all over n minus 1. So we're going to use the two of them to ascertain if we're obviously going to get the same thing. So let's proceed further. Now my x is this. My x is 2, 2 and 3. X squared will be 4, 4 and 9. 8 plus 9, 17. 17 total here. 4 plus 3, 7 here total. So for the first one, okay, I think we're using the second one first. So if we are substituting our variables inside, I will have my x is equals to the summation of x squared. This is my x squared, which is 17, minus the x, which is this. Then square it, which is 7 squared over n. The number of degree of freedom, 1, 2, 3 over 3, all over n minus 1, which is 3 minus 1 is 2. So my x for standard deviation now becomes 17 minus 49 divided by 3. I have 49 divided by 3, I have 16.333. 16.3333. Let's take 4 variables over 2. So my x is equals to, now, 17 minus 16.3333 is equals to 0.6667 divided by 2 is equals to this 0.33335, and x is equals to the root of this. The root is the root of 0.33335 is 0.577. Okay, the next formula, let's see what we have. So this is our first answer. Let's use this other formula now. Now, for this other formula to compare the undergraduate and the postgraduate, which is supposed to be the same, let's have our round table. Don't forget, okay, let me put the answer there, 0.577. 0.577. So let's take this other one. So we're going to have a different table because their formulas are different. So in this other case, we have x minus mean, which is x minus x bar, which is the mean. And we have x minus x bar squared. We have to square it. So let's see what we have. Now the mean x bar is equal to the summation of x over n, which is 7 over 3. The total here summation is 7. The number of degree of freedom 3 over 3, which is equals to 7 divided by 3 here. Divided by 3 is equals to 2.33. 2.33. So this is our mean. So let's proceed now. 2 minus 2.33, I have 2 minus 2.33 is minus 0.33. Remember, the 2.33 is the mean. It says S minus mean in each column. The same thing goes here, minus 0.33. And the last one is 3 minus 2.33 is equals to 0.67. 0.67. Let's square them. Minus 0.33 squared. 0.33 squared. We have 0.1089. Summation of that is 0.1089 plus 0.1089, 2 cases, plus 0.4489 is equals to 0.6667. Now, application. From the formula, which is this, I have standard deviation is equals to the root of the summation of x minus x bar squared, which is 0.6667 all over n minus 1. 1, 2, 3. N is 3 minus 1. So this is equals to 0.6667 over 2 is equals to 6667 divided by 2 now. 0.33, 0.33335, and the standard deviation now becomes, which is 0.577. In both cases, 0.577, 0.577, which means we can use the same, or the formulas, any of the two formulas, we can remember them to get the same answer, and that's pretty good. Anyone you find easy or simple, You apply and you move on. Okay, we're going to move down to the pool standard deviation. Let's see what we get, because the principles of pool standard deviation seems different from the ones we've been dealing with. So we have to take them carefully, or look into them carefully, so that we'll be able to get what we want and deal with it perfectly. Okay. In pool standard deviation, remember I said they will be giving us more than one variable, which could be x, y, and z. So at least if we can solve two questions, we'll be able to see the differences and how this thing runs. Alright? So now, let's look at it in the manner in which it should be looked at. Now, we'll start with the easiest one if you ask me. You say calculate the pool standard deviation of the following experimental result. Let me clean the board. Okay, we should calculate the pool standard deviation of the following experimental result: x, y, and z. X is given to be 2.2. Now, the formula for pool standard deviation, let me bring it up first. Pool standard deviation is equal to the summation of x minus x bar square plus the summation of y minus y bar square plus the summation of z minus z bar square all over n minus k. Now, what is our n and what is our k? The n is the set of data that we're given. There are three sets of data, which are x, y, z. These three sets of data contain the element in the three sets of data are 3, 6, 9, 12. So our n is 12. Alright? It has to do with the element inside the various set of data. And k is simply the set, how many set of data we're given? 3. So our k is 3. So this becomes 12 minus 3, which should be 9 if we proceed further. So if this is our formula, it means in each case we have to know what the mean is, because x minus the mean, x minus mean square, we sum them, y minus mean square, we sum, z minus mean square, we sum. And when we get that summation, we now insert it into this formula and divide it by 9, which is 12 minus 3. 12 for n and 3 for k. So, if that's true, let's proceed then. I can take this out now so I can break down the explanation or the solution. So let's start with the x. So I have my x minus mean, x minus mean squared. My y minus y mean, y minus y mean squared. Z minus z bar, that's z mean, z minus z bar squared. So, these are all the parameters we're going to be dealing with. So let me put them down. I have here 2.2, 2.2, 2.4, 2.3, and the summation. This is where I put my summation. Now y is 2.2, 2.3, 2.4, 2.2. Okay, that's for y. And z is 2.2, 2.4, 2.3, and 2.2. Okay, this is what we are. Now let us move further. Now, sorry, we have to get a mean in each case. Mean is the summation of x over the number of degree of freedom 1, 2, 3, 4. The same thing, summation of y over the number of degree of freedom. So let us see or get our summations here. I have 2.2 plus 2.2 plus 2.4 plus 2.3. This is 9.1. Here is 9.1. X bar is 9.1 over 4, which is equals to 9.1 over 4 divided by 4 is equals to 2.275. 2.275. So let's see what happens here too. 2.2 plus 2.3 plus 2.4 plus 2.2. 9.12. So our y bar is the same thing as 2.275. Let's check here. 2.2 plus 2.4 plus 2.3 plus 2.2. 9.1, same. So our z bar will be 2.275 in all cases. So it seems going to make it easier for us. So let's say this minus the mean. We want to start that now. 2.2 minus 2.275. We have minus 0.075. Minus 0.025. Now let's square the 2.2. 0 minus 0.075. 75 square is 0.005625. 5625. 0.000625, which means the summation here will be the same here and here. So let's proceed. 0.005625 plus 5. So this is the summation of our x minus x bar square, y minus y bar square, z minus z bar square. So I have to put it into the formula now and proceed. I can take this out, but remember, don't forget what we've been doing so far in order that we'll be in alignment with the necessity. So here, this is equals to my x is 0.0275, 0.0275. This is 2. That's the square plus 0.0275 plus 0.0275 all over my n, 12 minus 3, which is 9, and this is equals to 0.0275. If you multiply that by 3, you have 0.0825 over 9. Calculate this now. Okay, 0.825 divided by 9 is equals to this. So this is equals to the root of 0.00916667, which is equals to the root of that is 0.096. 0.096. approximately. So this becomes our pool standard deviation of the three given variables. What I've not confirmed is to solve them separately and add them all together and see if we get the same thing, which I strongly believe we will. So that is our first question on pool standard deviation. Okay, let's see if we can get another question on that so that we can move on. A new complexometric method was developed for the determination of chloride in industrial effluent, where the chloride ions were used as a complexing ligand. The result obtained from the new method was compared from the result obtained from the standard precipitation method, and the values were reported as follows. So we have the new method and the old method, and the different variables are also given. All we need to do is to get the pool standard deviation, the standard deviation of the pool standard deviation of the old method and the new method, or together. So let's move further or forward quickly. Let's call it N for new method and S for standard. So we have our N variable here is so we want to get the pool standard deviation of the two, the standard, the new method, and the standard method. So I will bring in the formula, but let's proceed first. We have our x here, which is this. We have 24, let's start with n, not x first, which is 20.10, 20.50, 18.65, 65. We'll have n minus n bar, which is the mean, and we're also going to have n minus n bar squared. Okay, and we are going to get in our x side, we have x. Okay, we have 18.20, 19.00, 19.20. We have x minus x bar, which is the mean, and x minus x bar squared. Quickly, let's run down. This one we have two variables, unlike the other one that we have three variables. Two set of data. Yeah. So we have minus the mean. So let's know what the mean is by summing up. 20.10 plus 20.50 plus 18.65 gives us 5925. 59.25. Our n bar, which is the mean, will be 59.25 divided by 123, which is equals to, divided by 3 is 19.75. 19.75. Then here again, 18.20 plus 19.00 plus 19.20. 56.4. summation of x over n, which is 56.4 over 3, which is this. Okay, that divided by 3, 18.8. 18.8. Okay, quickly. 20.10 minus 19.75. 19.75 is equal to 0.35. 0.35. Square that. We have 0.1225. 00. So we sum them up. The summation of that will give us 0.895. 1.895. Then. The same thing goes this way. 0.56. Okay. Now we've gotten this variable, so we have to bring in our pool standard deviation. So we say the pool standard deviation is equals to the root of the summation of the new method, which is n minus n bar squared, plus the standard method, summation of x minus x bar squared, all over n minus k. And this is equals to our new method, the summation of the variables in the new method, which was this, is 1.8950 plus that of the standard method is 0.56 all over. We have two set of data, and in the two set of data we have 2, 4, 6 variables then. So our n is 6 minus the set of data are 2 minus 2 for the n minus k. This is equals to, excuse me, I have my 1.8950 plus 0.56. This is the root of 2.455 over 4. Okay, 2.55 over 4. So when I divide this by 4, 2.455 over 4. So when I divide it by 4, I have 0.61375. And the root of that would be 0.78. 0.78. So the pool standard deviation of the standard method and the new method was 0.78. So we have been able to show from the beginning the standard deviation comparing the secondary level, the undergraduate level, and the postgraduate level, that the standard deviation is the same. As we advance further, the error margin decreases maximally because the variable for the secondary level, if you should carry that out with that of the undergraduate level, like 30 or thereabout, you realize that the difference is there. But that of the 38 and the postgraduate, which is MSc or PhD, they are the same, equivalent. So we can use any of those two as we proceed. And we'll be able to also see that in the full standard deviation, instead of carrying out because of the set of data are 2 or 3, instead of carrying out the standard deviation individually, we compress them by using one formula to attain that. And don't forget, n minus k, where the n is the variables in the two set of data, or 3 as the case may be, or 4, like you encounter in time to come, and the k here shows the individual variables in the set of data, be it 3, 4, 5, or 6. And when you do the calculation, like here we have 6 in all minus 2 set of data, and at the end of the day we have our 0.78. So that is how it goes. Do have a nice day. Thank you.